Hey guys, welcome to the first day of robotics class. So I'm really excited to start this new project with you guys. As I mentioned, it's going to be something that I haven't done myself before, and so we're going to explore together. We're going to invent together, which I think is one of the most fun parts of engineering and robotics. So for today, the first thing we want to do is talk a little bit more about what robotics actually is. We touched upon it last week, but today I actually want us uh, to write them down, to take some notes. So one of the things that I gave to Mr. Ramos were these little engineering journals. So today I would like you to go ahead and grab your journals and take some notes in there. Real quick on that, why do we want to take notes as engineers? Well, the first thing is that you want to write things down because we aren't like computers. We don't have perfect memories. So there's going to be a lot of things that I tell you guys, a lot of things that we do that you're going to forget next week, a week late, 2 weeks later, or a month later. And that's totally okay. That is normal. But the thing that can help us is that if we write that stuff down, we can look like, a month, 2 months later, we can look back at it and be like, okay, yeah, it's right there in our notes. So that's one of the reasons why we want to take notes. And number two, the other reason that we want to take notes is that it's not just for ourselves, it can also be for other people, it could be a classmate who's saying like, oh, I forgot how to do this. Like they can actually take a look at your engineering journal. Or who knows, maybe a sibling, a parent, right? Someone who just like, oh, what's going on in robotics class? They can check out your engineering journal and can actually learn from it too. So two reasons why you write things down. Number one is for yourself so you can remember, and then number two, so that other people can learn from it as well. All right, so super important that we take notes in this class. We also call it sometimes the playbook, like in football or other sports. It's like you have a book with plays in there, and if you sometimes you forget the plays or forget whatever's going on that you need to know for the team, it's in the playbook, so you can open it up and check it out so that you know what to do. Okay, so sometimes I call it the engineering journal, sometimes I'll call it the playbook. Either way, you take out those journals and then jot down those notes. All right, guys, so let's go ahead and take out our journals and let's talk about what is a robot, what makes up robotics. All right, so here we go. Robotics. All right, now there are four things that I want you guys to write down. Number one, we have, I'm going to write it down, body. All right, so every robot is going to have a body, and if something does not have a body, it's not going to be a robot. Now, what makes up the body of a robot? It could be metal parts, could be plastic parts, could be wood parts. Like that movie Baymax, I guess his body was kind of a balloon. It could be balloon parts. Okay, so it's not limited to like exactly what type of parts the body is made out of, but definitely a robot needs to have some type of body. All right, and then on this side, I'm going to say the type of engineering that has to do with the part. So the body, so all the physical parts of a robot, the type of engineering that has to do with that is mechanical engineering. All right. So if you really like those type of things, like if you think a movie like Iron Man, right? You think it's pretty cool, like the suit that the Tony Stark wears. Like if you think it'd be really cool to design that suit, you might be really interested in mechanical engineering. Or if you design cars, stuff like that, also mechanical engineering. All right, number two is the heart. And I like to say that the heart, let's see what happened here, heart. I want to say that the heart is the battery of the robot. That is where the power source comes out. Now for the human heart, our heart pumps blood to go to the entire body so that our body can function. All right. Now for the robot, the battery doesn't pump blood, obviously, it pumps electricity. All right, and so electricity is like the blood of a robot. A robot needs electricity everywhere in order to work. And the type of engineering is electrical. All right, so if you like playing with electricity, if you heard of things like circuits, it's basically how to get things to turn on and off. All right, if you're into that kind of thing, you might be into electrical engineering. All right, what else we got? We got the brain. All right, the human brain is the place where we process information, we store our memories, things like that, and also helps us make decisions. A robot's going to have something like that as well, and that's going to be a computer, though, for a robot. And so it's called computer engineering. So people who design computers. So if you're into that kind of thing, like you know the differences between a Windows or a Mac, and you like one better more than the other. You maybe you're a gamer, and you know that in order to play certain games, you need a certain type of performance on your computer. Things like memory or processing speed. So if these kind of things, these kind of words are exciting to you, you might be someone who is into computers. So be like maybe a computer engineer. All right, and then number 4, we have called the personality. All right, so every robot is going to have some type of personality, and what I mean by that is that the robot will behave a certain way. Just like us as humans, we can behave a certain way, right? A robot behaves a certain way because of the stuff that's actually inside of the brain. All right. Now, the thing that controls how a robot behaves is called software. All right. So that's the stuff that it goes into the brain. The software goes into the computer. I'll draw like an arrow here. The software goes into the computer so that the robot can work. One thing I like to kind of paint the picture of, if you've seen the movie called Baymax, okay? Baymax, he was a robot that was designed originally to be like a nurse robot, to be a helping robot. And then what happens throughout the entire movie, so I won't explain the whole movie, but at the end of the movie, he's basically turned into a different type of robot, but a lot of the stuff stayed the same. Like his body basically stayed the same, his heart basically stayed the same, the brain even stayed the same. But what happened, the thing that changed was his personality. And so what's going on there is that the software is the thing that's being changed. All right? So you can have like the same mechanical, same electrical, and same computer, but if you change the software, it could change everything. All right? Okay, so let's move on and let's talk about this guy. So I like to always take our theoretical, like I just, back over here, I shared all these words right here, right? So what I want to do now is, okay, so I have these words that I shared over here, so let's talk about these words that in the context of WALL-E the robot. So WALL-E is another Disney movie that maybe some of us have seen. I saw it a few years ago. I thought it was pretty good. So looking at WALL-E, what is the body? What is the mechanical engineering stuff? Well, let's take a look. We have, I'll use blue here. We got the eyes, right? We got the 2 eyes. His little claws here, that's definitely the body. And his little tire tracks, or tank tracks, you know, those are like his wheels, which is part of his body, and then his kind of like torso part. So all these parts are part of the body, and so if you're a mechanical engineer, you would go and design like, okay, well, how am I going to get all these parts to fit together? What do I want to go with, tank tracks or like regular wheels, right? How am I going to make a claw? Do I make it with like 2 fingers or more fingers, or what? Maybe it depends on what he's trying to grab, right? So these, and then also like what kind of materials. If you remember, if you've seen it, Wall-E's supposed to like operate in space, so you probably don't want to use like cardboard, stuff like that, right? So you got to think about the right material that can, um, survive in space. So those are the things you want to consider as a mechanical engineer. All right. Then the next thing that I want to look at, okay, so where's his heart? Where's his heart? Well, his heart's going to be inside this case. And if you guys happen to remember from the movie, actually, it's thing. Sorry, guys, I'm trying to. Here we go. Yeah. Here, this is like his power meter or his heart meter, right? Like a lot of things have, it's like the battery status of how much charge is left. And so this tells how much juice this guy has, or I like to say kind of the blood of the robot. So once his juice or his blood runs down all the way low, he stopped working. And actually, there's a part in the movie where he stops working because he runs out of battery. So that's one example of like, yeah, if the robot does not have blood, quote unquote, or electrical charge, he can't operate. And the battery, I think, is probably like inside here, in that little cube like torso area. That's where I would figure his heart or his battery is. All right, another thing that we would want to point out is where the computer is. Now the computer, so here's the thing about robots, like the brain or the computer is not always here, like in the head. For humans, our brain is obviously in our head, but for robots, it's like their heart, their brain, it can be anywhere. So usually the brain and the heart and stuff, it's like all in one area, and it seems like it's probably all in this cube here. Okay? So in there is going to be a computer, and that's where all the information, like his how he's going to behave, how like his memories and stuff, that's where it's going to be stored. So the computer, again, like going back to here, the computer is the brain, right? It's the place where the memories and also the personality, like that's where those things stay, or they live, right? But it's not the actual memories. The actual memories, the actual personality is something else. And that's what we call the software. All right, so that's something that we want to make sure we don't get confused about. Okay, I'll say it one more time. Like, the brain is a thing. The brain is like the house for the personality. But the personality is a different thing, right? So you could have a brain, which is like a house, but you could have an empty house. So you could have like a robot that has a brain, but no personality. And if that happened, the robot can't really do anything. And so going back to here, there's actually an example. At the end of the movie for Wall-E, he actually, his brain is still working, but his personality gets like erased. So it's like he resets. So his brain works, his body works, his heart is working and everything, but then when he wakes up, it's like he forgot everything about himself, like he's a brand new person or something. So in that situation, his brain, his body, his heart's working, but his personality, something got deleted, something got messed up. So that's a perfect example of everything's working, but the personality got messed up. So that kind of gives us kind of like a foreshadowing, or what I mean is that like something to look forward to. Like when we start getting to the brain and the personality of all our robotic stuff, that's when things get really interesting, because you could, like the situation I just explained to you guys, the brain, the body, and also the heart could be working totally fine, right? So like those three parts are working totally fine, but it could be an issue with the personality. And that tends to happen. So that can be really frustrating, because going back to here, guys, look how many things need to come together for a robot to function. 4 things, right? And this may be one of your first times working on something where so many things could go wrong, right? So if one of these things go wrong, your robot's not going to work. And so that's something I want you to kind of just keep in mind. Now, we're not going to do all 4 things all at the same time at first, because if I just said, okay, we're going to work on the body, heart, brain, and personality all right now, all today, that might be a little bit too much, because we're not, we got to get good at, we got to get good at each one by one, and then start putting them all together. Okay, but I want you to just keep it in mind that like it will get kind of crazy when all of those things, we try to put it together, and I don't want you to get frustrated. It's okay. Like, we're going to go through this together, okay? Now, the other side of that is like, okay, it seems kind of hard, right? All 1, 2, 3, 4, all those have to go be working well together. But the flip side of that is, I think it's pretty interesting. It's pretty rewarding too, right? Like, if you can get all 4 things working together, that's something that could be fun, getting it all working, and then like something you can be proud of. Like, look, you did all these 4 components, got them working. All right, so enough of that. That's just something I'm excited about, like in the future, that things that we're going to work on together. Now today, we're going to focus on. I'm going to do some circling right here. We're going to not the body, not the personality. We're going to work on the heart. And then, maybe I'll talk a little bit about the brain, but not really, but you'll see. But today mainly is going to be the heart. All right, so I'm going to move over now. I'm going to change the camera here. All right, so inside our kits, I want you to take a look at this bag here, okay? And what we want to do is we want to grab one of these bags here. There's should be 4 of these actually, and there's a little light, so we want to take out the little light. Okay. All right. Now, all we're going to do today, guys, is try to turn on this little light, all right? And I want you to look at this light, and I want you to notice that they have 2 legs, all right? And if you notice, one leg is longer than the other, a long one and a short one. And what we want to know right now, remember, is that the long is plus, all right? And the short is minus. The long is plus, and the short is minus. So I'm going to show you guys how to turn this thing on. So first, like, easy question, all right? Why is my light not on right now? Why is it not on? Someone might be thinking, maybe a lot of you guys are thinking, because there's no battery, there's no power, right? This thing is not going to turn on without power. Perfect, yeah. So we need to give it some power. So that's where this thing comes in, guys. So this Uno, it says Uno on here. This is actually the brain of our robot, all right? Now, things kind of get a little bit confusing. Like, I get it, so I'm going to try to explain it as best I can. This is a brain, but also inside of it is also a heart. So I guess you can think of it as like it's a brain and a heart together. All right. So what we're going to do is we're going to see if we can turn this light on, okay, by connecting it to this brain, which also has a heart in it. All right, I'm going to go back over here and make a drawing. I'm going to draw what we're going to call a schematic, okay? And you guys can draw this with me. Okay, so we have the Uno, which is the brain heart thing, right? All right, and then we also have the LED, which I'm going to draw like this. There's a plus and a minus. And just in case we forget, for the LED, the long is plus and the short is minus. Okay? So why is it a triangle with this line? This is a symbol. So whenever we draw, whenever we work with trying to design or trying to plan to our circuits on paper, we're going to use these symbols. All right. All you got to know is that this side, this triangle, this part of the triangle is going to be the plus, and then this line here is the minus. And the plus is the long leg, minus is the short leg. It'll make more sense once we actually connect it together. All right. Now we're gonna on the Uno brain thing. There's a 3.3V, and there's a GND. Okay. So let's check that out. Let's check it out. Okay. So if you look here, and it might not be super clear on the camera here. I might be a little bit out of focus, but if you look at this, if you look on this side, you're going to see 3.3V, and you're going to see GND. All right, and then next to it, there's just next to the 3.3V, you'll see a silver circle. Okay, ignore that. We're not going to use that, but then you keep on going, and then there's going to be like a square black hole next to it. All right, this is going to be the 3.3V pin header. All right, that's what I'm going to call it. So these little black rectangular holes is going to be called a pin header. So if I say I want you to look at the 3.3V pin header, that means find the 3.3V white writing, and then move over to the silver circle, but we usually ignore that silver circle, and then move over again to the black rectangular hole, which is the pin header. Now going down, you'll see there's a GND, and in fact there's one, two. There's another one over here. So, but on this side there are two GNDs. It doesn't matter which GND. Okay, they're the same thing. They're just like multiple GNDs, which you'll realize over time why there's so many. But for now, it's just like, yeah, either one of these GNDs is fine. And same thing. You're gonna say GND. You're gonna go over to this like the metal circle, and then keep going, and then you find the pin header. Okay, so I'm going to put this down here, and I'm going to see if I'm going to go back to our drawing. Okay. So what we want to do is we want to connect 3.3V to the plus and the D to the minus. All right. So if we do that, what's going to happen is that the power will come out of the 3.3V, go into the LED and then back to the GND. So if we do this, electricity is going to flow like this through the light back to the GND, and then it's going to turn on. So why does that work like that? We'll talk more about that later. For today, I just want us to experiment with seeing if we can turn this light on by doing this. Like, why does it work? Just trust me, it's going to work, and then we'll go deeper into it in the future. Now, there's something else that's missing here, guys, because if I go back, this thing, if I go back and we look at the stuff, look at our components, right? We have the Uno heart thing, and then we have this. If I connect this, it's still not going to work, because what needs to happen is that we need to connect this to a computer or to something that has like a USB charger or something, okay? Because then that's going to give this thing power. All right, so I'm going to go like this, take this cable, right, and then I'm going to take this other side right here, and I'm going to connect it to my computer. So you could do that to a Chromebook, or maybe a neighbor's got a Chromebook. We just plug it in so that, okay. And once we do that, you're going to notice, guys, that this light, you see this light turn on? There we go. So that means we now have power. All right, so what's going on here is that this is the brain, okay? And then inside here is some heart stuff going on, okay? But the real heart, I guess, is actually coming from the computer. So the computer right now is acting as like the battery. And then the battery is connected through this blue cable or USB cable. All right, so if I take that off, see the lights turn off, and I just basically took my heart away. So let's put the heart back. Now we have power and a brain. Okay. Now that those lights are on, let's see if we can make this connection. All right. So give me a second here. All right. So what I've done here is I now have our little drawing up here so that we can follow along as we try to do this. Okay. So here's our light. We need to connect the plus, okay, which is the long leg right here, to 3.3. So then I can just take it and put it into the 3.3V pin header. Cool. Now the problem is, like, okay, now the short leg sticking out right here needs to go into the GND pin header. So I guess I can skip it. So I might need to do this, separate the legs a little bit. 3.3 and GND, and there we go. The light is on. So right now what's happening, right, is the battery or the heart is being fed from the computer through the cable into this brain thing, and then now I'm able to put my light in and take electricity from the heart to turn my light on, and I'm doing it through the 3.3V. All right, and I just want you to be careful. Next to the 3.3V, I'm going to take this out. Next to the 3.3V, there's a 5V as well. Don't do the 5V, all right? That's going to be too much power, and I'll explain more about that next time. Make sure we're in 3.3V and GND. Okay. Now, there's a little bit more time. What I want to do now is I want you to pull this guy out. Okay? This here is something called a breadboard. All right? And what I want to do is just something really simple. All right? I want us to take our LED, and I want us to bring the legs back so that it's back to normal. Okay? To like the normal width, okay? And then I want us to then take it and put it here. All right. You're gonna notice on this breadboard thing with all these holes, you got a red column going down here, a red column over here, a blue column here, and a blue column here. All right, the way that the breadboard works is that all these holes, they're there for a reason. And some holes are connected to one another, and some holes are not connected to one another. So there's kind of a trick to know which holes are connected and which holes are not connected. Now, when you know that, you're able to then put stuff in different places and then make different kind of connections. So the first thing that I want you guys to know is that you see this red line here. That's like a really easy reminder to tell you that all of these holes down this column, like this red column, those are all connected together. And then over here, all the blue ones, this blue column, those are all connected together. All right. So what I want you to do is go ahead and you're going to find these wires right here. I call them pin to pin, okay? Because it means that you got a pin on this side and also a pin on this side. And I want you to take a black one out and one red one. Okay? I always like to, you want to use red for plus and black for minus. You could also use blue you can also use for let's just always use black. That's something that a lot of all electrical engineers are used to, okay? And so it helps us to like not get confused in the future too, because later we might have a lot of wires. So let's always use red for power or plus and black for a minus. Okay, so then what we want to do is take the red one and we want to put it into 3.3V like that. And then I can just put it here on one of the holes in the red column. Okay. And then what about the blue column, right? I can take the black wire and put it into G and D pin header, and then put it on the blue column on one of these holes. I'm going to put it right there. All right, make sure you guys can see this. Okay. It's not on because remember the heart is coming from the back from the computer. So I'm going to plug it in, and look, it's working. Okay. So if I take like the black wire out, it turns off. And remember I said that all of these holes on the blue are all connected. So look, I could put it down here. It works. Down here. Over here. All of those works. Oops. All of those work. Okay? And then same thing with the red. If I can pull that out, it's not going to work anymore. But any of these holes work. Okay? Now, you might think, okay, that's cool, Coach Ed. Now, what about, you said all the blues, right? Blue is connected. Blue is connected. But look, there, it's not working. It's not working. Right? Not working. So, okay, so the problem is that all these holes on this blue line, those are connected, and all these are connected to each other. But this blue line and this blue line, they are not connected. All right? So that's why it doesn't work if I do this and put it in there. So I just have one challenge for you guys. Now that we know a little bit about these red and blue columns, there's I want you to take a orange wire, okay? You can put this orange wire on the breadboard, like one pin. So basically putting this wire into the breadboard. So selecting two holes on the breadboard, sticking them in, you can get this light to turn on. Okay, so right now it's not on, right? Because you have a red wire here and a black wire over here on this blue column. Now, how can you use this one orange wire to get it to turn on? Okay, my hint is that something needs to be connected to this leg of the LED, because right now this leg is not connected to anything, because if you go down the column, look, there's nothing connected to there, right? So that's a problem. This red this long leg over here is connected to this red wire right here, so we're good there. So this part's fine. All right, so that's the challenge. Give it a shot, and we will learn more moving forward. All right, hopefully that was interesting. I will talk to you guys later.